We're going to start the kinematics of angular motion. Before starting the lecture, I would like to give a quick example and definition of kinematics of angular motion. The kinematics of angular rotational motion describes the relationship among the rotation and the linear properties. Just suppose that we do have momentum, mv. Now whenever this momentum turns into circular motion, this pretends that it is now a kinematics of angular motion. That probably means the quantities are turning with respect to the radius on the path of the circumference, and the distance is measured in mostly of radians, revolutions, and third quantity is degree. Let's move on to the kinematics of angular motion that we're going to discuss today. Today, our topic is about angular displacement. Normal displacement is the vector quantity that defines the distance from one point to another. That is also termed as the shortest path between point A to point B. As it is, in the angular motion, whenever there is a circular path that has a radius, this is this point, the central point of the circumference is termed as radius of the circle. And the distance is termed as also radius. This is the circumference. And let me give you a quick example. This is the diameter. And diameter is basically equal to pi. And our whole circle is equal to 2 pi. So this distance is known as the radius. And here we got the displacement. Now here, if I term this point as A and this point as B, a body is moving from this point towards this point. It is making an angle that is termed as theta. This point, like point A, is with respect to the radius. So this is r. And if we talk about the piece, that if I define this piece, so this is arc. That is also a part of the circle. So this arc is denoted by the S. So if we talk about the displacement, so displacement can be measured by the theta. That probably means the angular displacement is denoted by the theta. Here, theta is equal to S upon R. That probably means the distance covered by the S from point A to point B is divided by the R to get the displacement. We can also derive another unit from theta is equal to S upon R. That probably means that if you are given that find out the S, the arc length. So it can be S is equal to R multiplied by theta, where S is the displacement arc length, R is the radius of the circular path, and theta is the angular displacement. It is a vector quantity. There are some terms that you will heard about the angular displacement. That is the whole circle. If I talk about one rotation, I meant to say that just suppose that a body is standing here and it rotates on the circular path and again comes at the same point. That probably means that it is of measure of 360 degree. 360 degree is equal to 2 pi. Now here, if we talk about the degrees, so if the whole circle is composed of 360 degrees, so what is 1 degree is equal to? 1 degree is equal to 0.07175 radian. As I taught you that radian is also a term by which we measure the displacement as well as the circular motion. So radian can be transferred into the degree by simply multiplying. Just suppose that I want to know that what is 1 degree equal to. What I will do is simply multiply 1 by pi upon 180. That pi is equal to 3.14 and I will get this answer. What if I want to know that what is 1 radian is equal to? So basically 1 radian is equal to 57.3 degree. How we transfer radian? So basically here we multiply it by 180 and divide it by pi. This is how we derive the formulas. I hope that you get the formulas. Thank you for watching.